Hello friends, I welcome you in lecture number 8 on binomial distribution. In this lecture also we will discuss one more problem on binomial distribution. So let's try to understand what is given. The probability that one of the 10 telephone lines is busy at instant is 0.2. What is the probability that 5 of the lines are busy, and what is the probability that all the lines are busy? So first we check whether the random experiment in this problem is binomial random experiment or not. So here it is given that there are 10 telephone lines. Okay, here we can consider n equal to 10, where 10 is the number of telephone lines, and for each telephone line there are only two possibilities: either telephone line is busy or telephone line is not busy. And these 10 telephone lines are independent. That one telephone line is busy does not depend on the remaining telephone lines. And it is given that probability that one of the 10 telephone lines is busy at instant is 0.2. So this probability remains constant for each telephone line. So if we consider random variable x equal to, number of busy telephone lines. So the possible values of this random variable are, capital X are small x equal to 0, 1, 2 up to 10. Okay, so there are chances that no telephone line is busy, there are chances that one telephone line is busy, and the maximum possibility is that all the telephone lines are busy. So these are the possible values of x. And suppose we define success as a telephone line is busy. So we define this event as success. So it is given that probability that one of the 10 telephone lines is busy at instant is 0.2. So we are given that this probability of success is 0.2. So it is given that probability that telephone line is busy, that is probability of success, is p equal to 0.2, and this remains constant for each telephone line. So we can see all the conditions of binomial random experiment are satisfied. Therefore this random variable x is a binomial random variable, and therefore we can write its probability mass function. So therefore x is a binomial random variable, and its probability mass function is, we have standard formula for the probability mass function of a binomial random variable. It is given by NCX, probability of success raised to x, 1 minus probability of success raised to n minus x, and x is from 0, 1, 2 up to n. So we substitute values of n and p here. So n is 10, there are 10 telephone lines, probability of success is 0.2, and 1 minus 0.2 is 0.8 raised to 10 minus x, and possible values of x are 0, 1, 2 up to 10. So this gives me the probability of x successes among 10 lines, and success is the event that telephone line is busy. So this gives me the probability of x telephone lines which are busy. Okay, so using this probability mass function we can decide the probability of x telephone lines which are busy. So now we see what is asked in first part A. It is asked that what is the probability that 5 of the telephone lines are busy. So here we will consider small x equal to 5. The probability that 5 telephone lines are busy this is equal to probability that capital X equal to 5. So in this right hand side we put x equal small x equal to 5. So we have 10c5 0.2 raised to 5 and 0.8 raised to 5. So if we use scientific calculator we will obtain these values. You can verify using scientific calculator. I have obtained these values, and last one is 0.32768, and if you multiply all these things you will get 0.026424115. You can write up to 3 or 4 decimal places. I have written up to 9 decimal places using scientific calculator. So the probability that 5 telephone lines are busy is this one, 0.026424115, or if we round off up to 4 decimal places it is 0.0264. So we have obtained the probability of 5 busy telephone lines using probability mass function formula and scientific calculator. And if you are not interested in using this probability mass function, you can directly use cumulative binomial tables to find out this probability. Okay, we can write probability of x equal to 5 at probability that x is less than or equal to 5 minus probability that x is less than or equal to 4. Now using cumulative binomial probability table we can find out these two values. So I consider this binomial probability table. So we find out here number of trials, that is n is 10, probability of success is 0.2, and first we require this probability that capital X is less than or equal to 5. So I will consider small x equal to 5. So capital small n is 10, small p, here they have denoted probability by capital P. In our case we are considering small p. So probability of success is 0.2, small x is 5. Okay, so if we consider this row corresponding to x equal to 5 and column corresponding to small p equal to 0.2, we obtain this value 0.9936. This I can write as 0.9936. And if I am interested in probability that x is less than or equal to 4, so I will concentrate on this row. Okay. So I remove this. So now I concentrate for x equal to 4 and p is 0.2. So if we consider this column corresponding to p equal to 0.2, row corresponding to x equal to 4, and we obtain this value 0.9672. So these probabilities we substitute in our calculations, 0.9936 minus 0.9672. 0.9936 minus 0.9672. This we obtain using binomial table for small n equal to 10, p equal to 0.2, x equal to 5 and x equal to 4. And if we simplify this, we have 0.0264. Okay, so we obtain same value up to 4 decimal places. So if you are not comfortable with calculations, you can use binomial probability table also. So that is your choice, or as per your conveniency. Either you can use this formula for probability mass function, or you can use binomial probability table. Both are easy. Okay, fine. Now we consider second part, part B. In part B, what is asked? We have to find the probability that all the lines are busy. That means small x equal to 10. So now we find out probability in part B. Probability that all the telephone lines are busy. So that means probability that 10 telephone lines are busy, that is capital X equal to 10. So we substitute in the formula of PMF. So in this formula we consider X equal to 10. So we have 10 C10, 0.2 raised to 10 and 0.8 raised to 0, that is 1. So that we write here 10 C10, 0.2 raised to 10 and 0.8 raised to 10 minus 10, that is 0. 10 C10 is 1, this is also 1. So we have 0.2 raised to 10, and if you use scientific calculator, your answer will be up to 9 decimal places. You will obtain this answer. So this is the probability that all the telephone lines are busy. If you round up to 6 decimal places, then also you will get 0 answer. So it is very small probability. Probability that all the telephone lines are busy is very small. That is, we can see it is tending to 0. Okay, so in this way we can decide this type of probabilities using binomial probability distribution. So this is all about this session. I hope you like it. Thank you very much.